All right, so Olivia, tell me what to write, to put in my calculator.
I had 6.08, and then parentheses 1 plus 0.0121,
Very good,
and then parentheses X.
perfect. That's the formula we talked about yesterday, right? If it's increasing, it's addition. If it's decreasing, it's subtraction. The percent has to be moved, decimal point has to be moved, what? 2 to the left. Cola.
Do we use this in Half-Life?
Yeah, I think we do.
That's where I remember.
Yeah, for decay and radioactive stuff, yeah. Okay. So, we put that in. 6.08 parentheses 1 plus 0.0121 to the x. Right? We don't have a t like they, like we had in the book, right? We had to use x. Right? And we're adding because it's increasing, right? If it said decreasing, we would have just put a minus right there. That's only different, right? Okay? So, how are we going to be able to see it? What did we have to do yesterday? Most of them we couldn't see. Zoom 0, right? So zooms up top middle and 0, and then it'll start doing it for you. Okay? All right, so the first problem, will we say growth or decay? Growth, right? Because it's increasing. All right? Use a graph to predict the population in 2020. What year was this? 2000. So I could go to the graph or the table, and what X value would I be looking at? 20, right? So second table, we got to go down to 20. I could do this. Let me do it this way. Second table set started at 20. So 7.73 billion.
I got 9.2. I don't know.
All right, so the other way to do it on the graph was to hit what button, Jordan? Trace. Where's the trace button? Pay attention. Where's the trace button? Next to the graph. Okay, when you hit trace, it starts at the y-intercept. Just hit the right arrow, and I want, it's going to take a while, but I want that to go up to, I want to just get 1. So you're going to have to hold it down. It's going to take a while. All right? But you can do it that way. Another thing you can do is this. We didn't look at this yesterday. If I do value, that means to put an X value in. What's our X value going to be for this problem? 20, right? From 2020 from 2000 to 2020. Invalid, huh? Probably because it doesn't show the 20 there. Okay? So I guess we have to go back to the table. All right, so 7.73. All right, if we moved I guess we could try, let me try this once. Let's see if we go zoom out once. All right, let me try that this time. Second trace value 20. Yeah, there's a 7.73. So I hit zoom 0 to fit it. And if that happens to you, you put the value in that you're looking for, X value in, and it says it doesn't work like mine did. If you hit zoom out, enter, it'll zoom out for you, and then you probably could do it that way. Okay? So what's this one? Growth or decay? Decay, because it says decreases, right? All right, so what's my equation? The original amount, initial amount, whatever you want to call that, 1 minus, because it's decay, decreasing. What's my percent? 30, so what is that here? 0.3, 2 places to the left, to the x power. Okay? So we go back into our y equals and clear that out and put 3,000, parentheses, 1 minus 0.3 to the x. Hit zoom 0. All right, and that's decay, right? Decay starts and then it flattens out, right? Growth starts kind of flat and goes up. All right, let's see if we can do the value. 4 years. So we hit second, trace, value, put 4 in for x. So $720.30. Or we could go to the table, right? And I'm at 20, so I'm going to start it at 4. And there's $720.30. It depreciates pretty quick, doesn't it? $3,000, and only 4 years later, you can only get $700 out of it. What happens with cars too? Okay, going over those two, did that help? Yeah. That's exactly what we went over yesterday, isn't it? The only one homework problem that wasn't like that was the first, number 6, the first word problem, because of the bouncing. What was it, a softball or something? Okay, so we started at number 2, right? And number 2. There it is. Stay where the shows growth or decay. Okay, so 0.5 was the base. When it's between 0 and 1, what did we say? Decay. All right, so number 2 is decay. All right, number 4 is 3/4. So that's another decay, right? It has to be bigger than 1, that base, whatever's being raised to the x power has to be bigger than 1 to be growth. Between 0 and 1, a fraction or decimal, decay, right? A decimal less than 1, right? If I had 1.23, that's still growth, right? Even though it's a decimal. You with me on that? We got that. We understand when it's growth and decay. Nicole? You zoned down on me already. Number 6. It says a new softball dropped onto a hard surface from a height of 25 inches, rebounds to about 2/5 the height on each successive bounce. Okay? So it's a little different, this one. It starts out at 25 inches, but we don't know if it's an increase or a decrease, right? So it's not really an increase-decrease type problem. It just says how much it bounces. So you just put the 2/5 there. Okay, so that's, and I think I told you that. Maybe I didn't. Okay, maybe it was 6th period I told you. All right, so that's a trickier one because it doesn't say it's growing in so many, just, it's decreasing, I guess. So we could do 1 minus 2/5, or 3/5, right? If you wanted to do it that way. So anyway, it says graph it. It's gonna, when you put that in the calculator, and again, you just do a quick sketch of it. Okay, I should have hit zoom 6, or zoom 0. Zoom Zoom 6, well, it probably won't show up because of the 25. All right, so zoom 0. Let's see if it's a little bit better. It looks about the same. All right, then we go to our table. And, you know, when you start, it's at 25 inches high. After the first bound, it bounced up to 10 inches. After the second bounce, it went up to 4 inches. Third bounce, it went up to 1.6 inches. And then fourth bounce, 0.6 inches. Okay? And you had to see how many bounces before it was less than 1 inch, right? So it would be 4 bounces would be the answer to that. Okay? Number 8, that was growth, because it was 1.3. Number 12, that was no, or 10, sorry. It says the amount of freight transported by rail in the United States was about 580 billion ton miles in 1960 and has been increasing at a rate of 2.32% per year since then. Write a function. All right? So, you just use 580. You don't have to put 580 billion. All right, what number is this? 10? So the total amount equals the initial amount, 580, and it's increasing, so it's addition, and it was 2.32%. So remember, that's 0.0232 to the x. Thank you, sir. You just got here, Brandon?
Yeah.
Okay. All right, so there's our equation. Use a calculator to graph it about, or it says graph, in what year would you predict that the number of ton miles would exceed 1 trillion? So you're looking for 1,000, right? They told you it was 1,000 billion. So it's going from 580 billion to 1,000 billion. Okay? So you'd have to go into your table, right? So that was 580, 1 plus 0.0232 to the x. And just go to the table. All right? So I'm looking for when that gets to 1,000. Not the x value, that's the y value. There you got your 24. So 24 years, which would be 1984. Because year 0 was 1960, right? Does that make sense? Better sense? Okay. That's all that matters, so we got it now. All right, number 12, that was not exponential because what's my exponent? 10, right? If it's a number like we're used to see it, it's not an exponential function. It's when the x is up there is what we said, right? And 14, it's 0.5 to the x, so that would be yes, it is an exponential function. So 12 was no, 14 was yes. And then 20 said it gives you, for a certain credit card, the total amount that you owe for n months is given by this formula. It's 1.015. So they give you the formula to the nth power. N, what did it say n represented, Kennedy? What? Number of months. Okay. So it says, suppose that you begin with a debt of $1,000, graph the function for the amount that you owe. So that's how much you owe. That's what the P is. All right. So you go in here and you put 1,000. 1.015 to the x. All right. Zoom 0. So there's our graph. Graph the function. How much will you owe after 1 year? Okay, so my x is 1, right? So I could do this. I could go second trace value, and I put 1 in. Oh, 1 year though is how many months? 12. So I got to put 12 here. Okay? So if you put 1, you forgot that and the x was number of months. Okay? You guys laugh at me because I tripped?
Yeah.
It's all right. I'm a little old sometimes, you know. All right, so on this one, you got to remember that, you know, again, it's months, the exponent, so you have to put 12 in. So if you put 1 in, you were thinking right, but not really. That would be just for 1 month instead of 12 months. So there's that $1,195.62. Okay, that's the answer to part B. It says, how long will it take for the amount that you owe to reach 1,300? Okay, so you can hit trace if you want and go up and look for 1,300, which would be 17, almost 18 months, which is 1.5 years, right? Or you could go to your table and look for the 13, which would be right there between 17 and 18. Okay, Trent, quit zoning out. All right, so do we understand this better? Okay. You're supposed to do this worksheet before you leave. I thought we'd be done. A little quicker, but you got time. So get this done and show me before you leave to get your 5 points for homework. But it's actually classwork. I think that's it. Well. Okay, back here, Laramore. Let's do that. Front and back, people, front and back. Front and back.
Oh, I thought it was Larry. Good. What do you need, my dad? So.
And no flyers?
No, my dad doesn't care about looking at it.
My grandma's
Like
got
we played football.
Why? What's the matter with you?
I didn't do nothing.
You did it all wrong. What's this supposed to be? The negative sign?
Yeah, it's
Okay, did you put minus sign? Okay. You didn't do nothing, you did it wrong.
You wrote 2020.
It's 2021, right?
Yeah.
All right, so get that worksheet done, please.